Hi students, this is Karthik Trivedi and you are watching a lecture series of engineering graphics and design with me. So in today's video lecture, we're gonna see a new chapter called Conic Section. So before we start this chapter called Conic Section, it is very important to define what is conic section. So let us define conic section. So as you can see a definition on your screen, which is ellipse, parabola and hyperbola are called conic sections because these curves appear on the surface of a cone when it is cut by some typical cutting plane. So here he's talking about three important things. Ellipse, parabola and hyperbola are called conic sections. So when you say conic section, that means you are talking about ellipse, parabola and hyperbola. Okay, so these are the conic section. Why these are conic section? That we will see later in this video. Okay, because these curves, so these are the curves, appear on a surface of cone. So you can see that this shapes appears on a surface of cone. That means these all shapes derive from the cone when it is cut by some typical cutting plane. So cutting plane, what is a function of cutting plane? So cutting plane is used to cut a particular object. So here the object is cone. So what we gonna do over here, that we are having a cone. Okay, so assume a 3D geometry called cone in your mind. Okay, so now you are having a cone, visualize 3D geometry in your mind, and now you are going to cut this cone at some particular angle by some cutting plane. So cutting plane is you can take it as a hacksaw, you know, that we use for cutting something. Okay, so here cutting plane is used for cutting the object. So you are having a one cone over here and you are going to cut this cone by cutting plane at some certain angle or at some certain position. Okay, and after cutting this cone, there is some shape which is appear on the surface of the cone. That shape that we are going to derive by cutting the cone is ellipse, parabola and hyperbola, and as this shape is derived from the cone, that's why ellipse, parabola and hyperbola are called conic section. But now question comes in your mind, so why is it so? So let me take you to the explanation. So now here see, very importantly, now you will have a one cone. So here you can see that green color, it is a basically cone. So it is a 3D geometry, but you are going to see only front view of this cone. So you can see that front view of cone is over here, the cone which is 3D geometry. Okay, and the side of this cone is called generator. So when I am say generator, that means I am talking about the side of the cones, which you can see it from the front view of the cone. So you can see that front view of the cone is on your screen and the side of this cone is called generators. Okay, and now you can see the axis of the cone is also over there, a dotted line. You can see that vertical dotted line which shows the axis of this cone, and side of this cone is known as generator. Now let us cut this cone by some cutting plane, but from where? So look at on your screen very carefully. Again I am going to repeat. See, this is the cutting plane. Again I am going to repeat. See, this is the cutting plane. Okay, so from here we are going to cut this cone. Again I am going to repeat. See this, where we have to apply the cutting. So here look at on your screen very carefully. So this is cutting plane. Okay, here where we are going to cut this cone. So from here now we are going to cut this cone, and you can see that the section plane, when he's talking about section plane, that means he's talking about the cutting plane. Okay, so we are going to cut this cone by cutting plane. So when I am say section plane, that means I am talking about the cutting plane. So here can section plane through generator. So what we are going to do, we are going to apply cutting plane through this generator. So you can see that we are applying cutting plane such that it is passing through both the generators. Okay, so when we are going to apply cutting from here, which you can show on screen, again I am going to repeat like this. You are having this cone, and from here you are going to apply a cutting plane. Now what will happen? The cone will be cut in two parts. So what you have to do? You have to remove the first part and throw it away, and the remaining surface or remaining portion of the cone will be look like this. So you can see that the remaining portion, or you can see that the surface of the remaining portion of the cone will be look like this, and this surface is gonna look like ellipse. Okay, so we have derived, basically what we have done, we have derived ellipse from the cone. Same way we are going to derive parabola and hyperbola from the cone. So let us take another example. Again, here you can see the cone over here. The front view of the cone is over here. You can see the two sides of the cone, which is called generators, and the vertical dotted line, which is axis of the cone. Now what we gonna do? Let us apply cutting plane, but here at some other position. So what is that position? So you can see that cutting plane over here, look like this. See again on your screen, again see on your screen. Okay, so this cutting plane is parallel to what? Parallel to one of the generators. Generator means one of the side of the cone. Again see, look at the cutting plane over here. Okay, yes, from here we are going to apply cutting plane. Now what will happen? First portion will be removed, and the remaining portion of the cone will be look like this. So you can see the surface of the remaining portion where cutting plane is applied. So you can see that shape you are getting, which is look like parabola. So this is how you can derive parabola from cone. Now let us go for hyperbola. How to derive hyperbola from the cone? So let us see the cone over here. So you are having a cone over here, and you can see that vertical dotted line, which is axis, and the side of the cone is known as generator. So you can see the front view of the cone over here. Now what you gonna do? Now let us apply the cutting plane over here. Okay, so let me apply cutting plane, something like this. So you can see this cutting plane over here, which is parallel to what? This cutting plane is parallel to the axis of the cone. Okay, so now apply cutting over here. The first portion will be removed. What you have to do? First portion will be removed, you have to throw it away, and the remaining portion of the cone will be look like this. The surface of the remaining portion, you can see that shape you are getting on the remaining portion, which is going to be look like this, and it is look like what? Yes, you are right, hyperbola. This is look like hyperbola. So as you have seen over here, you have derived three geometry: ellipse, parabola, and hyperbola from the cone by cutting the cone at a various positions. So this is how you can derive ellipse, parabola, and hyperbola by cutting the cone by section plane. So that's why as we are getting this shape ellipse, parabola, and hyperbola from the cone, so that's why the ellipse, parabola, and hyperbola are known as conic sections. Okay, so now you will understand why ellipse, parabola, and hyperbola known as conic sections. Okay, so now we will see one of the method of drawing ellipse. But before we gonna do that, let us define a common definition of ellipse, parabola, and hyperbola. So you can see that the common definition of ellipse, parabola, and hyperbola is on your screen. These are the loci of points moving in a plane such that ratio of its distance from a fixed point and a fixed line always remain constant. So what kind of points they are? They are points for them what? So they are the points moving in a plane such that the ratio of its distance from where? Distance from fixed point to the distance from the fixed line always remain constant, and this ratio is known as what? Eccentricity. If this ratio is less than 1, then the curve you are getting is known as ellipse. If this ratio is equal to 1, then this is known as parabola. If this ratio is greater than 1, is known as, then that curve is known as hyperbola. Now here I am talking about some fixed point, and also here I am talking about fixed line, and here I am also talking about the loci of points. But now we are not going what this fixed point is, what this fixed line is, and how, sir, what is the eccentricity, how we are going to get this ratio, that we will deal later in another video. Okay, so that's why we are just here focusing on one of the method of drawing ellipse, but this we are going to explain in some other video. Okay, so right now we are going to focus on one of the method of drawing ellipse. So here you can see that now we are going to draw ellipse by concentric circle method. So now we are going to see one of the method of drawing ellipse, and this method is known as concentric circle method. So here example is something like that. Draw ellipse by concentric circle method. Take major axis 100 mm and minor axis 70 mm long. Okay, so whenever you have to draw ellipse, you will having some data something like this by concentric circle method. So you are having a data like major axis 100 mm and minor axis 70 mm long. So first draw a horizontal line which is major axis equal to 100 mm. Okay, now from the midpoint of the major axis, so midpoint will be what? If the major axis 100 mm, midpoint will be 50 mm. From 50 mm, draw vertical line equal to minor axis, and we have the dimension of minor axis what? 70 mm. So from midpoint draw a vertical line 35 mm above, 35 mm below. So now horizontal line shows major axis which is 100 mm and vertical line shows minor axis which is 70 mm. Now we are going to give a name. So major axis, which is 100 mm, is known as AB, and the minor axis, which is 70 mm, which is known as CD. So here, when I say major axis, means I'm talking about AB. When I say minor axis, I'm talking about CD. Okay. Now what we have to do? Now we have to draw a two circle. So first circle that we have to draw from center, taking AB as a diameter, and another circle that we have to draw by taking CD as a diameter. So here, first I am going to draw a one small circle by taking CD as a diameter from center, something like this. So you have to take one circle taking CD as a diameter. Now you have to draw another circle by taking AB as a diameter. So now you will have another circle. So now we have drawn two circles. First, by considering CD as a diameter, we have drawn one circle, and another circle that we have drawn by considering AB as a diameter. Now divide this circle into 12 equal parts. So as you can see on your screen, we have divided this circle into 12 equal parts and give numbering. Here I have given numbering in anti-clockwise. Okay, you can also give it in a clockwise. Choice is yours. Now what we gonna do? Now from the outer circle, I am going to draw a vertical line. So here you can see that I'm going to draw vertical line, but before I'm going to do that, also you have to give the numbering in inner circle also. So we have given the numbering in inner circle as well. Now what we gonna do? From bigger circle, which is outer bigger circle, from each division we are going to draw vertical line. So upper part of big circle, from each division we are going to draw vertical line in downward direction. So from 1 I will draw vertical line downward direction, some random distance. From point 2 I will draw vertical line in downward direction. From point 3 I will going to draw vertical line downward direction, but that are going to be coinciding, so no need to draw that. From 4 point I will going to draw a vertical line downward direction. From point 5, now no need to draw from point A and B. Why? Because you know that ellipse is always passed through major axis and minor axis. So your point A, B, C and D, these 4 points is always fixed. So no need to do anything from that points. Okay. Now from the lower half of the bigger circle, we are going to draw a vertical line but in upward direction from each division. So what we going to do? You can see that over here from point 10, I am going to draw a vertical line but in upward direction. From point 9, vertical line of some random distance in vertical upward direction. From point 7, from point 6. Now what you have to do? Now from inner circle, from each division you have to draw horizontal line. So something like this. From point 1 you have to draw horizontal line. Whenever going to intersect, we are going to give point. From point 2 you have to draw horizontal line. No need to do from point 3, because we know that point 3 itself is point C and point 8 is itself is point D. So you already know the ellipse is always passed through the point A, B, C and D. So whenever you are point A, B, C and D, no need to do anything over there, because ellipse is going to pass through the point A, B, C and D, because it is passing through major axis and minor axis. Now from point 4 draw horizontal line. From point 5, from point 6, from point 7, from point 8, which is point D itself. So no need to do anything from there. From point 9, from point 10. So you can see that all the intersection, you are getting the intersection. From bigger circle you have drawn vertical line, and from inner circle you have drawn horizontal line. So whenever this intersection happen, you have to give it a point like this, like this. So these are the all intersecting point. Okay, something like this. And you always remember A, B, C and D, this 4 point is always fixed. Now draw a curve passing through this point, something like that. Okay, here something like that. Yes, so the shape which you are getting over here is known as ellipse. So this is how, by using concentric circle method, you can draw ellipse. I hope you will like this video. Have a nice day. Bye bye.